Hey everybody, I hope you're doing well, and I appreciate you getting back into the swing of things here. Today we're going to do just a really short overview of the features of quadratic functions, aka the features of parabolas here. Next week, we're going to start to look at what do these equations tell us about the graphs? You'll notice that both of these graphs have equations written down below. So again, that's what we'll be doing next week is we'll be looking at those equations and what they tell us about graphs, but I want to make sure that we've got some of that vocabulary down beforehand. So some of the important vocabulary here when it comes to parabolas, the first one is the vertex, right? And the vertex is the turning point of the graph, right? It's if we've got a U-shaped parabola, the vertex is the turning point here. So I'm going to label these actually not. I'm going to label these graph A and graph B instead of left and right. So graph A has a vertex at the coordinate point -2, -1. That's where the graph turns around. And then graph B has a vertex at the coordinate point 2, 7. So the vertex is a really important feature, and again, next week we'll talk a little bit more about that. Something you might notice down here, we've referenced this before, is talking about the value there. We have graphs that open upward or open downward, right? If they're opening upward, that's a thumbs up, that's a smiley face. If they're opening downward, that's a thumbs down, that's a frowny face. Another word that we could use instead of opens upward or downward is concave up or concave down. So when we're talking about whether something is concave up or concave down, really we mean what direction does it open? What direction do the ends of the graph go to? So if it's concave up, the ends of our graphs go upwards forever. If it's concave down, the ends of the graph go downward forever. Besides the vertex, another important feature that actually works alongside the vertex is called the axis of symmetry. Zoom in just a little bit there. The axis of symmetry. And so the axis of symmetry is an imaginary line. It's not actually a part of the graph, but it's an imaginary vertical line. It goes right through the vertex. And basically, if you think about this line, the graph is perfectly symmetric on either side of that line, whether it's 3 units away or 2 units away. It's perfectly symmetric from one side of the line to the other. And since this is a vertical line, we're always going to write it of the form x equals something. And remember, that's going to be some sort of number there. So for graph A, our axis of symmetry is x equals -2 because every value on that point has an x value of -2. And for graph B, that axis of symmetry is going to be x equals 2. And you might notice that the axis of symmetry and the vertex, -2, -2, +2, +2, those are always going to match up perfectly. So we've got the vertex, we've got the axis of symmetry. Those features are pretty unique to parabolas. Some things that are not unique to parabolas, some features that you've heard before. One of those is the y-intercept, right? And that's where it crosses the y-axis. That's where x is equal to 0. So graph A, we've got the y-intercept right here at the point 0, 3. And remember, as a coordinate point, we always want to write it as an x and y pair, 0, y. For graph B, we've also got the same y-intercept. That's kind of funny. I didn't even realize that. 0, 3. So just make sure that we have those coordinate points exactly as they should be. Another feature that is familiar is an x-intercept. And remember, an x-intercept happens where the graph crosses the x-axis. So for instance, on graph A, we have 2 x-intercepts. We have x-intercepts at the coordinate points -3, 0, And at -1, 0, and again as coordinate points, we want to be listing both of those values. Graph B's x-intercepts aren't perfect whole numbers, but we can kind of approximate them. So maybe this is 4.750 or -0.750. And in a few weeks, we'll be looking at, how do we find those x-intercepts precisely? But for now, on a graph, it just happens to be the points where the graph crosses the x-axis. And then one more thing I want to talk about here with our features. So we've talked about the vertex. We've talked about whether something is concave up or concave down. We've talked about the axis of symmetry, the y-intercept, the x-intercept, and then the last two bits and pieces that we need to talk about are the domain and the range. So remember, the domain refers to the x values of the graph. The range refers to the y values, all the y values that are allowed. And one thing to remember for our parabolas here, our quadratic functions, that the domain is always going to be the same for all of these quadratic functions. Those arrows that go up and up forever, they also go to the left and to the right forever, which means that our domain for every parabola is going to be all real numbers. Oops, let me rewrite that a little bit. All real numbers. And so remember, when we say all real numbers, that's a fancy way of saying everything from negative infinity to positive infinity, right? Everything from the very, very most negative numbers to the very largest numbers. But you're going to see all real numbers a little bit more frequently there. And then our range depends on whether our graph opens up or whether our graph opens down. So for instance, graph A opens upward, and all of those y values, the lowest y value is at our vertex, -2, -1. And so our range here is going to be all the y values that are greater than or equal to -1, because it reaches -1, but it never goes below that. It only goes above. Whereas graph B, this vertex is a maximum, right? It's the highest point on the graph. So its range is going to be y is less than or equal to 7, because 7 is the highest y value. Every other y value on this graph is below it. So, like I said, this is just a super short summary of these features. You've heard all of these words at least once before, and you're going to hear them many, many more times. And we're going to practice, how do we find these features if we don't start with the graph? What happens if we start with the equation? So we're going to get lots of practice with them. Today is just kind of a quick reminder. So check out that short quiz in Canvas. Make sure you're all caught up for the week with everything else. Make sure to send me some emails if you have any questions. And next week, we'll be getting into the real good new stuff. So I am excited to be moving ahead, and I will check in with you then. Take care, be awesome, and I miss you.